Okay, this is my original problem for chapter 3. A rigid tank is holding 12 kilograms of a saturated liquid refrigerant 134A and 8 kilograms of saturated vapor refrigerant 134A at 75 degrees Celsius. Determine the volume of the tank. So for the volume of the tank, that's going to be the volume of saturated liquid plus the volume of saturated vapor. And that's going to equal the mass of saturated liquid times the specific volume of saturated liquid plus the mass of saturated vapor times the specific volume of saturated vapor. Referring to our table for refrigerant 134A, temperature table at 75 degrees Celsius. We're also looking for the pressure. It is a mixture. So the pressure is going to be the saturation pressure at 75 degrees Celsius, so we could actually write that down. And that was 2365.8 kilopascal. Now, going back to the table though, our specific volume for saturated liquid and our specific volume for saturated vapor are equal to specific volume of saturated liquid is equal to 0.001037, and that's in meters cubed per kilogram and meters cubed per kilogram. So volume is equal to 12 kilogram times 0.001037 meters cubed per kilogram plus 8 kilograms times 0.00748 meters cubed per kilogram. And the volume is equal to 0.07228 meters cubed. Alright, so that's the volume of the tank. We found B, which was the pressure inside the tank. Now C, the quality. The quality is going to equal the average specific volume minus the specific volume of saturated liquid over the specific volume of saturated vapor minus the specific volume of saturated liquid. The average specific volume is going to equal 0.07228 meters cubed divided by 20 kilograms. That's going to equal 0.003614 meters cubed per kilogram. So now to get our quality, that's going to equal 0.003614 minus 0.001037 divided by 0.00748 minus 0.001037. So that's going to equal 0.39968, and we could really just round that to 4. So the quality is 4. And now we're looking for the enthalpy of the mixture. And the enthalpy of the mixture is equal to mass times the specific enthalpy which actually you could go about it two ways. The total mass times the average specific enthalpy, or whereas the average specific enthalpy is equal to the enthalpy of the specific enthalpy of saturated liquid plus the quality times HFG, but I like to just write it out. So that would be HG minus HF. So I made a pretty big mistake and I caught it. I accidentally rounded that to 4, and that should be That should be 0.4. Now you could get enthalpy in two ways. You could either use this formula, total mass times the average specific enthalpy, where the average specific enthalpy is HF plus quality times HG minus HF. Or you could do this and say enthalpy is equal to mass of saturated liquid times the specific enthalpy of saturated liquid plus mass of saturated vapor times specific enthalpy of saturated vapor. And I'll do both ways to show you that they add up. So I'll do this way first. So that would equal 12 kilograms times 164.98 kilojoules per kilogram plus 8 kilograms times 280.82 kilojoules per kilogram. That's equal to 4226.32 kilojoules, which is equal to 4.23 megajoules. Now the other way, right. And that, oops. And that as well equals 4226.32 kilojoules, which is equal to 4.23 megajoules. And that is the correct answer. So the correct answer for quality was 0.4. Pressure was the saturation pressure at 75 degrees C, which was 2365.8 kilopascals. And the volume of the tank, which I'm not sure that it's an original problem, and I'm not sure that my dimensions were up to par, but I got 0.07228 meters cubed. Thank you for watching and have a nice day.